Hello class, this is part 2 of your weathering lesson. So just to review a little bit what you learned in the last lesson about weathering and erosion, that weathering is the process of breaking down rocks and other substances at Earth's surface, and erosion is the movement of those rock particles. So today we're going to talk about the second type of weathering. We learned at the last lesson, mechanical physical weathering is when rock is broken down by physical means. But today we're going to talk about chemical weathering, where breaking down rocks occurs through chemical changes. So the types of chemical weathering are water, have to do with water changing rock, oxygen and rust, causing rust. Another word is oxidation, how CO2 changes rock, living organisms, and acid rain, which you probably studied in your social studies class. So here we have examples of where water breaks down rock, and so the rock has minerals in it, of course, and then some of the minerals we know are softer than others, if you remember your Mohs hardness scale. Well, some minerals like halite will dissolve in water. That's just salt. So if your rock has a lot of salts in it, then even just the water can break it down. Oxidation is a fancy word for when oxygen combines with water to make rust. And or it can be in the case of like this top of this building here, like the Statue of Liberty, where oxidation causes copper to turn green. When there's a lot of iron and water and oxygen, then that causes rust. So here are a couple of things I found on my walk. Fire hydrant was weathered chemically, and you can see the rust right here on this whatever cable box or whatever that is. And that's going to happen a lot in Georgia because we have a lot of rain, and where we live, a lot of chemical weathering happens. So I have a railroad track that I walk by frequently, and I noticed there was a lot of rust happening right there. Another example of oxidation. And here we have a top of a sewer. You can see the weathering happening there. And then also on the concrete beside it, the chemical changes are causing it to change color. Carbon dioxide can also cause weathering on rock. You can see this marble statue and how it's turned black over time through the carbon dioxide that's dissolved in rainwater to make carbonic acid, and this tombstone. So around town you'll see marble tombstones that look like that, and that's from the chemical weathering caused by carbon dioxide. Living organisms can also cause weathering in rock, and this is a really cool one. It's called lichens. Now the word looks like lichens. It is not pronounced lichens, it's called lichens. And what happens are these lichens produce weak acids that dissolve rock. They grow in rocks and make weak acids, but around where I live, I find a lot of them on my trees. So this is in my backyard actually, and no, it's not in my backyard, but it was on a walk, and this tree had a lot of lichens growing on it, and I know you've seen that. They are a life form that's a combination of two organisms that grow together, and that's fungus and algae. And so I do have a funny science joke, and if we were in my class, I would put it up as the meme of the month. So what did the fungus say to the algae? I'm liking you. And it just, sorry, my picture overshot the you, but that's the joke. What did the fungus say to the algae? I'm liking you. Well, the next one is one you've studied in social studies about acid rain. And you can see that as humans burn fossil fuels and cause sulfur, carbon, and nitrogen to mix with water vapor in the clouds, when it precipitates, it makes acid rain, and that will weather rock. Now, the rates of weathering, how fast weathering happens, depends on certain things. One is that how much surface area is exposed. So the more surface area that's exposed, the faster the weathering will occur. So it's if you look at this, if this was one large rock, you could see that weathering actually happens around the edges first. So this just has a few edges compared to if that one piece was broken up, you would see a lot more edges and then a lot more of the surface area here, the smaller it gets. So the smaller the pieces, the faster the rock weathers. Rates of weathering will also depend on the type of rock. Some rocks and minerals are more resistant to weathering than others. For example, quartz is resistant to chemical and physical weathering. Slate tombstones weather slower than marble tombstones. Rates of weathering will also depend on the climate. So cold and or dry climates favor physical weathering. So if you think about it, it makes sense. If you lived in a very cold place in Canada, you wouldn't have a lot of rain in warm, humid weather like Georgia. So you would have more freezing and thawing, you would have more abrasion, but warm and wet like Georgia, we favor chemical weathering. That's why when I go on my walks, I see so much rust. So that is